suppose we are required to prove that sine squared x plus cos squared x is equal to 1, which by the way it's a trigonometric identity. We normally refer to it as a square identity. So we are going to bring in a Cartesian plane. Let's refer to this as the x-axis. Then let this one to be our y-axis. So now we come up with a point here. Let's call it point P. Then we'll call it point P like this. Or we place it in the first quadrant. Let's call it point P, wherein we'll have x and y like this, making this one, the horizontal, to be an x, and then this one to be y, and then this side will just have r. Now we proceed. We check what is the definition for sine. We know that the definition, let's say we had sine theta, we know that it's opposite divided by the hypotenuse, and ultimately this is, according to the diagram, it's y divided by r. Then we also have cos theta, it's equal to adjacent divided by the hypotenuse. So in our case, our adjacent is x, our hypotenuse is r. And then let's quickly substitute. Let's choose the left hand side. We'll say left hand side is equal to sine squared x plus cos squared x. Moving forward, in terms of sine, we'll say this will be y divided by r, but everything is squared, plus, we quickly substitute, cos squared x is just x divided by r. Remember, this x in our case refers to the angle. The angle in question here, it's capital letter X. This is the angle in question, the angle that we are dealing with. You mustn't confuse the two. There is an x which represents the angle, there's an x which represents the side. So this one here is our angle, this one here represents our angle. This x here represents the angle in question. So now moving forward, we'll just have this one as y squared divided by r squared plus x squared divided by r squared. Moving forward, we can even apply the butterfly method or this approach. When we have a divided by b minus c divided by d, we can safely write this one as a multiplied by d minus c multiplied by b, sorry, this is b, all divided by b multiplied by d. So let's quickly apply that. Although we can see that we have the same denominator, so we can just have y squared multiplied by r squared plus x squared multiplied by r squared, all divided by r squared multiplied by r squared. Take out the common factor, we'll just have r squared into y squared plus r squared, sorry, this is x squared, sorry, all divided by r squared multiplied by r squared. We going to remain with these two, will divide each other. We remain with y squared plus x squared divided by r squared. But we know that according to the theorem of Pythagoras, if we are to apply theorem of Pythagoras for this particular diagram, we know that r squared is equal to x squared plus y squared. That means that we can safely replace x squared plus y squared with r squared. So it means that the numerator will just be r squared. We divide it by r squared, which will simplify to 1. And therefore left hand side is equal to the right hand side, and at the same time we are saying squared x plus cos squared x is equal to